Hello everyone, Professor Miller, and today we're going to talk about capnography. Capnography is used to measure the amount of CO2 my patient is exhaling. That tells me how well my body is working. CO2 is an end product of metabolism, and we're going to see how well my lungs are actually getting rid of that CO2. We talked about pulse oximetry earlier and how we measure for oxygen concentration in our patient's blood. Now we're going to measure the amount of waste that my patient is going to be breathing out. So we're going to go ahead and use this device called capnography or an end-tidal CO2 detector. And we're going to put this in our patient's nose. This one also allows us to administer oxygen if the patient so would need it. So we go ahead and apply that into my patient's nose, and we will wrap it around the ears of our patient to keep it in place. And then we'll go ahead and take this end and connect it into our monitor. And we can also go ahead and connect it to oxygen if necessary with this port here. When we hook our patient up to the monitor, you can go ahead and see along the bottom part the CO2 reading. And this is picking up my patient's exhalation. The flat part is inhalation. The up, across, and down is my patient's exhalation. And as you can see, it is currently 35. Our normal CO2 is anywhere from 35 to 45. And if we have it over 45, we find that my patient is acidotic. And if it's under 35, we find that my patient is alkalotic. Just depends on the level of CO2 in my blood. As we talked about earlier with our patient with a pneumothorax and the pulse oximetry decreasing because of the inability to get a lot of oxygen into my lungs, what happens when I have a pneumothorax? The end-tidal CO2 goes up because my body is not able to get rid of it as efficiently as if it would be that both of my lungs were functioning properly. Other causes of elevated capnography would be emphysema or COPD, a pneumonia perhaps because our lungs are all filled with mucus and we don't have the ability to exchange gas very well, or if somebody has heart failure and we have a lot of fluid in the lungs, we again are unable to inhale, exhale, and have good gas exchange. Because sometimes our patients aren't inhaling very deeply or exhaling as adequately as they possibly can. This device is another form of capnography, and this is one that can be applied to a breathing tube. And you see here that it is yellow. When it initially comes out of the package, it is purple. And this is a piece of litmus paper inside this device. And as the litmus paper is exposed to CO2, it will turn yellow. That way we know that we have a tube in the right place and that we are able to help our patient to breathe. Some of the other reasons that we may find that our end-tidal CO2 goes up is for drug overdoses. So that's many times why a person has the issues that they do, is that they stop breathing because of whatever drug it is that they have taken. How might my patient's end-tidal CO2 drop? Well, hyperventilation. If we start breathing really, really fast, my end-tidal CO2 can drop below 35. And what we do is we encourage our patients to slow their breathing down so that they can go ahead and bring that back to a normal level.